Okay, you guys, 8.2 is all about exponential functions and specifically graphing them, and what the graphs look like and what transformations happen to these graphs. If we remember from last time, exponential functions, the most basic parent function for that would be y equals some base to some exponent where the x is in the exponent, okay? Main things to remember, the base is so important. So the first thing we need to do is we need to identify what the base is. And remember that it will be a single individual number. It can be a fraction, it can be a decimal, it can be negative. It all just depends on remembering our exponent rules and knowing what is being raised to the exponent. So when we know what our base is, then we can start with our original points of the basic graph, which is, there are only three of them. And it is -1 and 1 over b, 0 and 1, and then 1 and b, with b being the base. Okay. And our graph, if b is greater than 1, meaning it's bigger, it's not negative. I guess I could say greater than 0. No, greater than 1. It is going to go up. It'll start really close. It'll have an asymptote and it will shoot up in the sky. But if b is between 0 and 1, meaning it's a decimal smaller than 1, it is actually going to go, it'll start up and go down like that. Okay, so just to be mindful, a couple special things about exponential functions. The domain is everything. You can plug anything in as an exponent, but the range, okay, the range is from 0 to infinity, but that will change based on our transformation. It is 0 to infinity because you cannot get anything smaller than 0 when you're raising a whole number to an exponent. Exponents don't make anything negative. Our horizontal asymptote, remember asymptotes are like force fields, that happens at the bottom. So your graph is going to usually just shoot up from that asymptote. Y-intercept is always going to be 0 over 1, and then the M behavior is on the right side, it goes up forever, and on the left side, it goes straight to 0. So, biggest thing you need to remember today is that all the transformations work exactly the same as they have before. So the first thing, this is all the extra fluff. Remember that the basic equation is y equals b to the x. So anything extra is a transformation. And the nice thing is they are exactly the same as what they've been before. So this a out front is our vertical stretch, and how we stretch it is we're going to multiply our y's by a. If a is negative, then it flips it upside down with a vertical reflection, okay, or a reflection over the x-axis. If a is small, it's going to make it shorter and fatter, all that stuff that we're used to, okay. B, big B is the base, but this B here is our horizontal stretch, and we remember it's tied to the x, so we do the opposite. Maybe it might be better for us to put this in parentheses, that whole exponent in parentheses, okay, because we're going to do the opposite, and I'm going to make a note maybe. We do the opposite of what it says to the x values, okay. C is our horizontal shift, meaning that's our left and our right. And again, it's the opposite of what we would think. So if it says +7, we'd actually -7. We'd go in the direction left 7. Okay. And then that last one that we have, the last one is K, and that is our vertical shift, which is our up and down movement. Okay. And the biggest thing I would say that I think is important to remember is that A and K deal with the Y values, okay? And B and C deal with the X values, and they're the opposite of each other, which is normal. We've done this about 8 million times, so it shouldn't be anything too crazy. So let's practice, okay? Here is our first equation. I'm actually going to zoom in so we can talk about it. If we remember, so maybe to help us out, I'm going to write the basic parent function as y equals this. For this one would be 2 to the x. Okay? All the other stuff is just extra fluff. And so first thing I'm going to identify my b, because that's going to tell me what my original points are, or my base. And my base equals 2, because 2 is what's being raised to the exponent. And so because my base is 2, then my original points, if I look back on the front side, my first x is -1, and I get 1 over b, or 1 over 2. The next point is 0, 1, and then the third point is 1 and b, so 1 and 2. So those are my original points, so I'm going to graph those just so we can see, and it's kind of tricky. So -1, 1/2, 0, 1, 1, 2. So if we notice, this graph would come flat in this direction, and then it's going to shoot up like that. Okay, that would be the original basic parent function, the green. However, we have a couple of transformations going on. First transformation that I notice, or the extra fluff, is the first thing I'm going to do is I'm going to go, okay, this is extra. And I look and I go, is that an A? Is that the B? Is that the C? Or is that the K? And that's actually our C, which means that we're going to move in the left or right. But because it says a -1, it is right 1, which means I'm going to add 1 to my X values. Okay? So I add 1 to my X values. I'm going to add 1. And so I end up getting 0, 1, and 2. So those are my new X values. Okay? And then the next thing I have, I look at the extra, and there's one more transformation, and that transformation is this -3, which is my K, which tells me that I'm going to go down 3, which is when I subtract 3 from my Y's. Okay? And it's okay if you have decimals. I don't care if it's decimals or fractions, but when we subtract 3, we get -2/2, -2, and then -1. So -2/2, -2, -1. So now I'm going to graph my new function. I'll just graph it in red. So first point is 0, -2/2. That's right here. Next point is 1, -2. That's right here. I could fix that guy. And then the last point was 2, -1. So if I look, it's going to be this graph right there. So I look at and compare my green and my red, and I go, okay, does it look like I moved it right 1? Yep. Those points have been all shifted over and down 3. So domain on this is going to every time be from -infinity to infinity, because I go all the way from my left to my right. Okay. And my asymptote, that's my vertical asymptote, it will always be in the form of a line, y equals, and that's going to be y equals k, where I've vertically shifted it. Okay. And so this is going to be y equals -3, because if we look at this graph, our graph is never going to go below that point. It'll just flatten out and get infinitely closer to it, but never quite touch it. Okay. And then we would say the range is from bottom to top, and the bottom of the graph starts at -3, but never quite touches it. And then it continues to go up to infinity. Okay. At any time, feel free to rewind or pause, or maybe challenge yourself and pause it and try to go to try to go go on and then check your answers, because this one's a little bit more difficult, but I think you could do it. Okay, with this one, we're going to zoom in a little bit. Biggest thing we need to be aware of here is that your because there are not parentheses, and this is kind of sketchy, okay? Because there are not parentheses like this, okay, around that -3. This is really the same thing as y equals -1, okay, times 3 to the x plus 1 plus 1, okay? The only time you would ever have a negative base is if it was super, super extra and it had parentheses around the whole thing, okay? So, in this situation, our base, or big B, is 3, which would mean that our starting points are at -1, 1/3, 0, 1, and 1/3, okay? So, when I graph those points, I get -1, 1/3, 0, 1, and 1/3. So this one's going to shoot up significantly faster than the one that we just did. But, and then we're going to look at our transformations and see what's going on. So the first thing that I notice is this negative out front, which is going to be an A value, okay? Which is going to actually, it's our vertical stretch, but it's not going to stretch it. It's actually going to reflect it across the x-axis or flip it upside down. So I'm going to multiply my y's, because up and down would change my y values, okay, by -1, or change the sign. So I'm going to multiply by -1. So I get -1/3, -1, and -3. First transformation. That's all the first of the 3 extra things that we have, okay? The next one is this +1, okay? And that is our C value, which is going to move it left or right. And because it is a +1, it's actually going to move it to the left one. And so I'm going to subtract 1 from my x's. Okay, so I go here and I go -1. So I get -2, -1, and 0. Okay, and then the last little extra bit that we have is this +1, which is a k value, which is going to move everything up 1. So we're going to add 1 to our y. I'm going to add 1. Okay, so in here I get 2/3, okay, or 0.66, whatever. -1 plus 1 is 0, and -3 plus 1 is -2. And so my final points are going to be point -2, 2/3, 0.66 or 0.67, whatever, -1, 0, and 0, -2. So I'm going to graph those points over here. At -2, I'm at 0.66. Okay. At -1, I'm at 0, and at 0, I'm at -2. So this graph is going to be flat and then shoot down. Okay. And then I'll answer my questions. The domain, again, the graph goes all the way from the left, so at -infinity, all the way to the right. And then the asymptote, okay, is going to be right here. Okay. If we remember, I said that's always the equation of the line, y equals k, so y equals 1. Okay. And then the range for this one, the bottom of the graph actually starts at -infinity and goes up to that asymptote at 1. Okay. If you have an assignment, it's rather large, and it's not all graphing, it's matching and doing a whole bunch of stuff. Do your best, and then check out the answer key that's on Canvas. I'll also have a paper copy located in the room somewhere. So Work hard, get it done, and when you're finished, turn it in the basket.